Am I audible? So much audible, man. So what I need to do is so much audible, man. Let me check how to share, YouTube links. How to share YouTube links on Instagram so that many more people click it and watch it. First of all, let me open this YouTube. How to share YouTube link on Instagram story.
Stop adding links to your YouTube videos in stories like this because Instagram opens them in the awful built-in browser and people can subscribe to your channel or like your video. But you can easily fix it. Create a story, tap the sticker, paste your YouTube link, and here write the word open. Tap adding links to your. Hi friends, in this video I will show you how to share YouTube videos on Instagrams of your Instagram ID and YouTube video has been shared on Instagram.
Henji. Henji. I wanna show it like not like a link, man, like a thumbnail or something, so that people could come. Henji. I wanna show it like. Hello, Michael. I'm Manideep, man. I thought you wouldn't come today because it's late night. I think there will be an option link in Insta story, I guess. Yeah, but I want to show like the video or something. Like a video, so that people like thumbnail. Oh yeah, or something. My classmates sleep, man. My classmates uh sleep at like very early. When are you going to sleep, by the way? Let me just put the link. I've put a screenshot of the thumbnail so that people can join. Okay, okay, okay. Even me, man. I plan to like study 4 hours today, but I never know, man. I just can't some days. I'll do more hour live tomorrow. I was at machine learning crash course by Google. Uh, I wish I could get the Codex, Codex, yeah, Codex subscription, because I want to study machine learning there. Now, how do I make this in dark mode? Oops, I can't make it in dark mode. People won't be joining, man. I don't have college tomorrow. Saturday, Sunday, I have holidays. Why did I delete this extension? Because it's very hard. We have dark mode now. What the hell? Dark mode. Please on yourself. Oh, what? What, man? Make it dark mode. Make it dark. Dark mode. Dark reader. We have dark reader. Yes, this is better. In the linear regression model, you explored how to construct a model to make continuous numerical predictions such as the fuel efficiency of a car. But what if you want to build a model to answer questions like, will it rain today? Or is this email spam? We can still use linear regression for that, right? Like we can put some features on it and find the correlation matrix and find out which feature is more related, and using that we could tell that. I'll see this video 1 second. Let me put on charge. Okay, 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 okay. I'm audible. I'm audible. Okay, so let's start. Let's see if I uploaded the story on the right place. Let's watch this video. I don't know if I will get copyright claim or something, but let's see.
Thus far in the course, we focused on building models that output a numerical prediction. For example, the amount of time it takes to drive to your destination. But what if we want to make other types of predictions to answer questions like, will it rain today? Does my car need a new transmission? Is this email spam? Let's take a closer look at that last example. Suppose we want to create a simple spam filter which predicts whether an email is legitimate or junk. We collect some training and test data and train a linear regression model to predict 1 if an email is spam and
Yeah,
0 if it isn't,
that's what I said.
based on
For
the
the rain,
number of
even.
spammy words
Even for the rain, I said the same.
in the email text. Here are the results. Let's say we have an email that contains 10 spammy words. Is it spam? A score of 1 means spam and a score of 0 means not spam. But what about a score of 0.62? We can think of this score as an indicator of the likelihood that the email is spam. The lower the value, the less likely it's spam, and the higher the value, the more likely it's spam. But it would be more useful if a regression model predicted a formal probability, a value from 0 to 1, representing the chances the email is spam. This type of regression task is called logistic regression. So how do we get our linear model to output a probability? We need to transform the model to apply some limits so it outputs continuous values that fall within the range from 0 to 1, where 0 indicates a 0% chance an email is spam and 1 indicates a 100% chance it's spam. What mathematical function could we use to do this? Two curves that may come to mind are an exponential curve and a hyperbola. Both functions produce outputs that approach a limit in at least one direction, but neither function's range is constrained to values between 0 and 1. What if we combine the two formulas? Here, we've created a curve whose output is squished between values 0 and 1. As the input
I didn't
decreases
understand
in
shit
time,
she
and
said,
1
bro.
indicates a 100% chance it's spam. What mathematical function could we use to do this?
What mathematical function could we do to do this? That uses probability. Eh? Which mathematical function is used for for probability in graph? Continuous data. Oh, okay. The probability density function. Bro. Something went wrong. This should I? Is it logistic or exponential, and why? The logistic function, specifically the sigmoid function, is primarily used for probability such as in logistic regression because it maps any input value to the probability between 0 and 1, which grow unbounded. The logistic function forms an X curve ensures probability do not exceed 100% or fall below 0%. Okay, so logistic function makes sure that it stays within the range, like it makes a XS curve, and the standard logistic formula converts raw scores. Okay, this makes
Two
sense
curves that
now.
may come to mind are an exponential curve and a hyperbola. Both functions produce outputs that approach a limit in at least one direction, but neither function are an exponential curve and a hyperbola. Both functions produce
Hyperbola.
mathematical function could be used to do this. Two curves that may come to mind are an exponential curve and a hyperbola. Both functions produce outputs that approach a limit in at least one direction, but neither function's range is constrained to values between 0 and 1. What if we combine the two formulas? Here, we've created a curve whose output is squished between values 0 and 1. As the input decreases to negative infinity, the output approaches 0. And as the input increases to infinity, the output approaches 1. This curve is called a sigmoid, one of a family of S-shaped curves called the logistic functions, from which logistic regression gets its name. We can use it to map the outputs of our linear model to a continuous probability range. Now we can retrain our model to calculate the probability of spam for any value of our feature, the number of spammy words. Using a logistic regression model, we can predict that our email with 10 spammy words has a 69% chance of being spam. Note that in practice, a spam prediction model would likely train on additional features and use more sophisticated natural language processing techniques. Logistic regression is a popular technique for building models that discriminate between two possible outcomes, including classification tasks. We'll further explore these applications later in the course.
Okay. Uh-huh. Many problems require a probability estimate output. Logistic. Uh, Many problems require a probability estimate as output. Logistic regression is an extremely efficient mechanism for calculating probabilities. Okay. Practically speaking, you can use the returned probability in either of the two ways. Applied as is. For example, if a spam predictor model, okay, convert to a binary category such as, okay, you might be wondering how a logistic regression can ensure its output represents a probability, always outputting a value between 0 and 1. As it happens, there is a family of functions called logistic functions whose output has those same characteristics. The standard, also known as the sigmoid function, has a formula f of x is equal to 1 minus 1 by 1 plus e minus x e to the power of minus x. 1 by 1 plus e to the power of minus x. F of x is the output of the sigmoid function. Okay, e is the Euler's number, exponential. Okay, it's 2.718, and we have x is the input to the sigmoid function. Okay, so we have f of x, which is the output of the function, e is the exponential constant, and we have x as the input value. Okay, as the input x increases, the output of the sigmoid function approaches as the input approaches but never reaches 1. Similarly, as the output decreases, the sigmoid function's output approaches but never reaches 0. The following equation represents the linear component of a logistic regression model. So we have z is equal to b plus so-called log odds. B is the bias and W is the more weights. X is the feature values. Okay. A logistic regression value has the following bias and weights. Let me calculate. Logistic regression model with 3 features has the following bias and weights. Wait a second. Let me calculate. Logistic with 3 features has the following bias and weights. Okay. So the formula is z is equal to b plus w1 x1 plus w2 x2 plus w3 x3. So b1 is 1 and we have 2 into 0 is 0 and w2 x2 is minus 10 and we have 10. So it's like 1 minus 10 and 10 gets cancels and we remain with 1. So 1 should be the answer according to my Mark Zuckerberg as. What is the logistic regression prediction for this input values? How do I calculate that, man? 1 by 1 plus e power minus x. Hey? What? How do we do that? Do we just add all of this? Let me try. One by one plus 1 by 2.71. You have 2.71 plus 1 by 2.71, 2.71 by 3.71. That would be like uh, that would be in points, like more like 2 by 3. 2 by 3 is like point 1 point 6 or something, so point 6 falls. Oh damn, why am I so smart? Smart lagelu. I'm smart lagelu. Now how do I calculate this, man? But I did anyways. I did a prediction. I did a very good prediction. I'm very proud of myself. Models are trained using the same process as linear regression models with two green distinctions. Use log loss as a loss function, increase the square loss. Applying regularization is critical to prevent overfitting. In the linear regression model, you use square loss, also called L2 loss, true, as a loss function. Square loss works well for a linear model when the rate of change of the output values is constant. When the rate of change of the output values is constant, yeah, because it's a straight line, so you just square and you get problem. However, the rate of change of a logistic regression is not constant, as you saw in a calculating probability. The sigmoid curve is S-shaped rather than linear. When the log odds value is closer to 0, small increases in Z result in much larger changes to Y. Why? Oh, because it's in minus 1 to the power. Z is a large positive or negative number. The following table shows the sigmoid function's output for input values from 5 to 10, as well as the corresponding precision required to capture the okay. Mm-hmm. Corresponding precision required to capture the difference between. If you use the square loss to calculate errors for the sigmoid functions, as the output got closer and closer to 0 and 1, you would need more memory to preserve the precision needed to track these values. Instead, the loss function for logistic is log loss. The log loss equation returns the logarithm of the magnitude of the change, then just the distance from data to prediction. Mate, 1 by n is for like all the labeled examples in the data set, and we have what the hell. So we have like instead the loss function for logistic regression is log loss. The log loss equation returns the logarithm of the magnitude of the change rather than the distance from data to prediction. Log loss is calculated as follows. I don't know what the hell is this, man. If I is equal to 1 and we have yi log y dash I. Isham Mastani. दिए जाए. So okay, n is the number of label, I is the index of the example in the dataset. Okay, yi is the label for the ith example is your model's predictions. Okay, why is my dad calling? Once again. Big. So yeah. Uh, a mechanism for penalizing model complexity during training. If is a mechanism for penalizing model complexity during training is extremely important in logistic regression modeling. Without regularization, the asymptotic nature of logistic regression would keep driving loss towards zero in cases where the model has a large number of features. Uh, Nature of logistic would keep driving loss towards zero in cases where the model has a large number of features. Consequently, most logistic regression models use one of the following two strategies to decrease model complexity. One is L2 regularization, and another one is early stopping, limiting the number of steps to halt training while loss is still decreasing. Okay, okay. So we have understood. Mhm. Why is a linear model output a poor predictor of probability? It has a one weight per feature. It doesn't. It has one weight per feature. It does have one weight per feature. It only has one output value. I don't think that matters. And its predictions are not restricted to values between 0 and 1. Probably a sigmoid function never outputs the value 0 or the value 1. That's true. Applying regularization is less important in training models than it is for training. No. No, what the hell you mean? That's false. Which of the following options matches both linear regression and logistic regression with absolute loss function for mean squared error? We have log loss. Okay. Which of the following is an effective regularization technique for logistic regression models? Early stopping. Submit answers. One should be wrong at least. I don't know. 5 out of 5. Thank you so much, man. I'm so proud of me. I'm so proud of myself. I need to thank my dad, my mom, everybody. They have been very supportive to me. You earned the machine learning crash course, loss regression model. Thank you so much. You earned the learning badge. Thank you so much. What's next? In the loss regression, you learned how to use the sigmoid function to draw, for example, predicting Hanji normal output a value between 0 to 1 and to make variety predictions. For example, predicting that a given email has a 70. It's not to output product, but I get it for example. Classification is the task of predicting which of a set of a class an example belongs to. Task of predicting in this model, you learn how to convert a logistic regression model that predicts a probability into a binary classification model that predicts one of two classes. You will also learn how to choose and calibrate appropriate metrics to evaluate the validity of a classification model's prediction. Finally, we will get a brief introduction to the multi-class classification problems, which are discussed in more depth later in this course. Okay. Let's say you have a logistic regression model for spam detection that predicts a value between 0 and 1, representing the probability that a given mail is spam. A prediction of zero point 0.5 signifies a signifying a prediction of signifiers are like you would like to deploy this model in an application to filter spam into a separate mail folder, but to do so you need to convert the model's raw numerical output in one of the two categories, spam or not spam. To make this conversion, you choose a threshold probability called a classification threshold. Examples with the probability above the threshold values are then assigned to the positive classes. The class you are testing for here is spam. Okay, examples with a lower probability are assigned to the negative class, the alternate class. Okay, there's something called classification threshold in logistic regression, where the examples with probability above the threshold are assigned the positive class, and examples with the lower probability are assigned to the negative class. Suppose the model scores one email as 0.99, predicting that the email has a 99, and another email has threshold to be 0.5. The model will has both. If you set the threshold to be 95, only the email scoring will be. Then we have categorical data. Then we go with deep learning, crash course, Google. We also have Is Coursera like paid? I don't know. Let's continue studying. I was at logistic regression and thresholds and the confusion matrix. There we had like correlation matrix. Here we have uh, confusion matrix. What's a confusion matrix? The probability score is not reality or ground truth. There are four possible outcomes for each output from a binary classifier. Oh, okay. For the if you lay out the ground truth as columns and the model's predictions as rows, the following table called a confusion matrix is the result. True positive. Spam email correctly classified as a spam email. These are the spam messages automatically sent to the spam folder. A spam email misclassified as not spam. These are spam emails that aren't caught by spam filters and make their way into the big inbox. False, true positive, false positive, true negative. Okay. Notice that the total in each row gives all predicted positives and all predicted negatives. All predicted positives and all real positives and all negatives. The total of each column, when the total of actual positive is not close to the total of actual negative, the data set is imbalance. Okay, the number of true positive, so the number of left column, the total of left column must be equal to the total of right column. Then the data set is balanced, and distance of an imbalance might be a thousands of photos of clouds. When the rare cloud type you are interested in, say Voltus cloud, only appears a few times. Okay, let's watch this video.
You can think of model predictions as falling along a line between 0.0 and 1.0, where 0.01 means the model has 1% confidence that the given example falls in the positive class and 99% confidence that it falls in the negative class. 0.5 means 50% confidence that the example falls in either class. 0.99 suggests the model has 99% confidence that it falls in the positive class and 1% confidence that it falls in the negative class. By setting a classification threshold, we tell the model at what confidence level to divide predictions into the positive and negative classes. When the threshold is set at 0.5, all examples at 0.5 and above are classified as the positive class shown in purple, while all points below that threshold are classified as the negative class shown in yellow. Notice that several examples are wrongly classified. We can track the number of correctly and incorrectly classified examples in a confusion matrix. The threshold chosen should be set based on the business purpose.
True positive, false negative, and we have false positive and true negative
of the model, because some mistakes are more costly than others. As we increase the threshold, notice that false positives or yellow examples wrongly classified as purple drop to 0. If false positives are much more costly or risky than false negatives, it makes sense to minimize them. Choosing 0.67 might be a good threshold in that case. If the mistakes are roughly equal in cost, a threshold between 0.49 and 0.56 might be a better choice. Here is a highly imbalanced data set. What might be a good threshold value here? If you set anywhere between 0.92 and 0.95, that's a good choice. Note that these visualizations have been simplified. In reality, model predictions are messy floating point numbers. The points will not be stacked, but will fall all over the line overlapping with each other. Now try changing the classification threshold for different datasets for yourself.
Let me try, ma'am. Thank you, ma'am. Wow. So we have 7, 8. Threshold is 0.5. I think it's already enough, right? It's already right? It's already correct. This is already right? Let me put on ChatGPT. Is this the proper threshold? Just look and okay, that's probably right. Imagine phishing or malware detection classification model where phishing and malware websites are in classified level 1 and harmless website are classifies a legitimate what is this called legitimate website as malware. So this is like false negative, right? Hey, oh, false positive. My bad. In general, what happened to the number of false positive when the classification threshold increases? Classification threshold increases. Classification threshold increases, they decrease actually, right? What about true positives? What about true positives? False positive increases, man, as far as I know. Eh? False positive is increasing, right? Oh, okay. So both of them are decreasing. In general, what happens to the number of false negatives? So we have, I need to hide this, man. This is TPFP and TNFN. No, TPFN, TPFP and TPTNFN. Okay, all good. In general, what happens to the number of false negatives when the classification threshold increases? What about true negatives? Experiment yourself. When the classification threshold increases, it also increases. So both of them increase. Yeah. True and false positives. 1 second. 1 second. 1 second D. Tulasi Oh Manavi Okay, so true and false positives, then negatives are used to calculate several useful mathematics. Mhm. Total classification TP plus TN. Okay. Are used to calculate several useful metrics for evaluating the model. Which evaluation metrics are most mean depends on the specific model and the specific task. The cost of different misclassification and whether the test set is balanced or imbalanced. All of the metrics in this section are calculated at a single fixed threshold and change when the threshold changes. Very often, the user tunes the threshold to optimize one of these metrics. Accuracy is the proportion of all classifications that were correct, whether positive or negative. It is mathematically defined as all classifications that are were correct. We have accuracy is equal to correct classifications and by total classifications. So we have TP plus TN. Okay, okay, correct. Okay, okay. I understand this. The true positive rate or the proportion of oh man, my stomach hurts. I'm gonna end this here, probably. Yeah, I'm gonna end this, man. I can't do this. Bye bye, take care, have fun, love you, bye bye.